the third line of Balmer series of an ion equivalent to hydrogen atom has a wavelength of 108.5 nanometer. The ground state energy of an electron of this ion will be. So there is another ionic atom we have to consider. Okay, so for the third line of the Balmer series, so Balmer series N1 is 2, the first line is 3, second, this is a first line, second line is from 4, third line, this is a second line, first line, the third line is from n is equal to 5 to, obviously they should end at 2 only. So third line of the Balmer series, for third line of Balmer series, N2 is 5, N1 is 2. Okay. Next, this is hydrogen like atom, that is all, not hydrogen atom. So 1 by lambda is R Z square 1 by N1 square minus 1 by N2 square, 1 by N2 square. Now substituting, or you can write this as 1 by lambda R is equal to Z square, and this one is N1 square N2 square, this is N2 square minus N1 square. Okay. Now I have to calculate what is Z, because the number of atoms I have to find out. So then that is Z square is equal to N1 square N2 square divided by N2 square minus N1 square into lambda R, So N1 I can substitute, that is 2 square, N2 I have to substitute, that is 5 square, this is 5 square minus 2 square, and lambda is also given, lambda that is by R, no, lambda, okay, Z square it is, so that is by R, so 1 by 108 into 10 to the power minus 9 into 1.1 into 10 to the power 7. Calculating all this, I am going to get Z square equal to 4. I can roughly calculate this. See, this is 4, this is 100. 100 by 21, this is roughly 5. So calculating this, I am going to get Z square equal to 4, Z is equal to 2. Z is equal to 2. Now, this is nothing but a helium atom. So, what is the ground state energy of the helium atom? So, for helium atom, Z is equal to 2, ground state energy En is equal to minus 13.6 by N square Z square, that is the expression Z square. So for ground state N is equal to 1, for ground state N is equal to 1. So E1 is equal to minus 13.6 2 square by 1 square, because Z is its atomic number. So 13 4s are 52. So whatever more than 50, looking at the options, that is minus 54.4 electron volt, which is option C being the correct answer.